Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC C1242-14 indicates a low voltage signal from the brake booster pressure sensor 1 in the Honda Civic 2022 and later models. This sensor is critical for the proper functioning of the vehicle's brake system, as it provides necessary information about the brake booster pressure to the electric vacuum pump control unit. When the voltage signal from this sensor falls below a specified threshold, the control unit identifies this as an abnormal issue, resulting in the DTC being stored in the vehicle's onboard computer. Addressing this error involves inspecting both the sensor and its wiring to ensure functionality. It is essential to identify whether the problem lies within the electrical circuit or the sensor itself to ensure proper braking performance and vehicle safety. The brake booster pressure sensor 1 is a pivotal component that monitors the vacuum level to help with braking applications. It is usually mounted near the brake assembly, making it accessible for inspection and maintenance. This sensor provides real-time pressure readings to the electric vacuum pump control unit, which is responsible for activating the pump when necessary to ensure optimal brake performance. If this sensor fails or its output voltage drops, the control unit does not receive accurate data, leading to the DTC C1242-14. Understanding how this sensor interacts with the electric vacuum pump control unit helps diagnose issues effectively. Clarity on component locations is essential for carrying out necessary inspections and repairs efficiently. The possible causes for DTC C1242-14 can be broken down into three main categories. First, wiring issues within the sensor circuit can lead to a failure in transmitting the correct voltage signal, manifesting as a low voltage reading. This could include open or shorted wires, affecting the integrity of the signal. Second, a faulty brake booster pressure sensor may simply not provide accurate readings due to internal malfunctions or wear. Lastly, the electric vacuum pump control unit can also fail, thereby compromising its ability to interpret the sensor signals correctly. Each of these causes must be evaluated during the diagnostic process to identify the root issue and ensure effective repairs. Symptoms of DTC C1242-14 may vary, but they fundamentally revolve around the vehicle's braking system performance. Drivers may experience diminished braking efficiency, which poses a safety concern. Additionally, the brake warning light on the dashboard may be activated, alerting the driver to an underlying issue. Furthermore, onboard diagnostics may generate error messages indicating problems with the brake booster pressure sensor signal. Observing these symptoms warrants immediate attention to ensure that driving remains safe and compliant with vehicle safety standards. Understanding these symptoms can help in pinpointing the issue more effectively during troubleshooting. The first step in troubleshooting the DTC C1242-14 involves cycling the vehicle's ignition. Start by turning the vehicle to the on mode, activating the electronics without starting the engine. This allows the control unit to initialize all sensors, including the brake booster pressure sensor 1. Next, switch the vehicle to the off, lock mode, and wait at least 2 seconds. This waiting period enables the system to reset and clear any transient faults that may have been recorded. Finally, return the vehicle to the on mode once again to observe if the DTC reappears. This step is crucial for determining if the low voltage signal is a temporary anomaly or indicative of a more serious underlying issue. The second step in the troubleshooting process focuses on inspecting the sensor 1 supply circuit. Disconnect the electric vacuum pump control unit's 30P connector and the brake booster pressure sensor 1's 3P connector. Using a multimeter, check for open wires in the sensor 1 supply circuit, MP-SNSR1 supply. It is critical to ensure that the resistance is less than 1 ohm indicating good continuity. This inspection is vital, as high resistance or an open circuit can prevent the proper voltage from reaching the sensor, causing low voltage signals. If the resistance is above the threshold, further investigation is warranted, possibly requiring measurement of the wiring harness for damage or disconnections. The third step in the troubleshooting protocol consists of inspecting the Sensor 1 signal circuit, MPSNSR1 signal. Following the disconnection of the appropriate connectors, utilize your multimeter to verify that there are no short circuits to ground in this specific wiring. A short to ground would create a condition where the sensor cannot relay accurate data to the control unit, which would in turn trigger the DTC C1242-14. It is critical that this inspection is thorough, as any detected shorts would necessitate repairing or replacing the affected wiring. If no shorts are present, it indicates that the wiring for the signal circuit is intact and functioning correctly, thus narrowing down the concern to the brake booster pressure sensor itself. After troubleshooting and potential repairs have been completed, it is vital to conduct a final verification to ensure the issue related to DTC C1242-14 has been resolved. Begin by reconnecting all previously disconnected components, including both the electric vacuum pump control unit and the brake booster pressure sensor. Once everything is reconnected, clear any stored diagnostic trouble codes, DTCs, from the vehicle's computer system. This is typically accomplished via an OBD2 scanner. Following the clearing of codes, a test drive is recommended to allow the vehicle systems to monitor functionality during normal operation. Pay close attention to the braking performance and check if the DTC reappears, confirming effective resolution of the issue. To prevent future occurrences of DTC C1242-14, regular preventive maintenance is essential. Conduct routine checks on the brake booster pressure sensor and associated wiring to ensure that they are free from damage or corrosion. By monitoring these components and their electrical connections, potential issues can be identified early, avoiding more significant repairs down the line. Additionally, ensure that any replacement parts used during repairs are of high quality and meet OEM specifications. This attention to detail can provide assurance that the system operates at optimal performance and longevity. Documenting regular maintenance and inspections can also provide significant insight into any recurring problems, facilitating better troubleshooting in the future. In conclusion, understanding and addressing DTC C1242-14 is crucial for maintaining the safety and performance of the Honda Civic 2022 and later models. This particular DTC relates to a low voltage signal from the brake booster pressure sensor 1, which plays a vital role in the vehicle's braking system. Regular diagnostics, including the inspection of wiring and sensor functions, can prevent serious issues from arising. Monitoring the components through preventive maintenance not only ensures vehicle safety, but also extends the longevity of the braking system. Through methodical troubleshooting and repairs, vehicle owners can ensure their Honda Civic operates reliably and safely on the road. Please like and subscribe to the channel. See you next time.